Welcome to Module 4, Lesson 14. So, going off here, we're going to continue expanding, finding the area of shapes that aren't perfectly rectangular or perfectly square, but we're still sticking in the realm of rectangular-esque shapes and square-esque shapes. Anyways, today we're going to see if I can find the area by decomposing into rectangles or completing composite figures. So, I'm going to use this image right here to kind of exemplify both of those here. If that's even a word, exemplify. I don't know. Anyways, so there's two ways we can do this. Before, we could just kind of decidedly cut this here or cut this there and make two smaller rectangles of it because we also had little units, squares, all the way through here. Now we're not having those, so we can't use those to cheat in a way. Now we actually are having to use elements of the problem around to determine what's on the inside. So there's a couple ways of doing this. And so first thing I'm going to do here is I'm going to go ahead and cut it. Now you can cut right here or you could cut right there. I'm going to go ahead and do this one first. We'll try the other one as well to give an example. But we'll go ahead and I'm just going to continue dot this line all the way across to find out the area of these two separate rectangles, and I'll stick them back together. So I will have this one be labeled A in green, and then I'll have this one down here be labeled B in red, just so we know which one we're talking about here. So let's go ahead and do the green one first. Let's do A. Now, long story short, how do we find area again? The vertical side versus a horizontal side. That's what we need to do here. Now, this side is 2. This side is 5. Granted, this entire thing is 4, but we got to remember, we've done an invisible cut right there. So we are completely ignoring anything below this, which means this comes all the way across right there. And from this point to right there is 2 centimeters. So the entire thing is still 4, but from here to here is 2. And we know that because of this point over here. We don't really need to write that there, but I'm going to do it to help illustrate a point. Now, how do I find the area of A? Well, 2 times 5, as we have talked about in the past. 2 times 5, and they're both centimeters. So that would become 10 square centimeters. Now, let's go ahead and do the red one now. Let's find B. Now, B is a little unique here, because we got one side length, which is 3 centimeters, which is good, but we don't have either of the vertical sides, which might lead you to go, we can't solve this. Not sure how to do this. But remember, this is being made out of a larger object. And hypothetically, if I had 12 inches of, let's say, just rope, 12 inches of rope, a very small piece of rope, but then I cut off 3 inches off of that, so 12, and I'm taking away 3. Now I'm here. Well, what's 12 minus 3? 9, so I'm left with 9. So view these side lengths the same way. If from this point to this point, the entire thing is 4, if I cut right there and take away 2, what is left? Or, in other words, what's this plus this equals 4? So what plus 2 equals 4? 2. 2 centimeters plus 2 centimeters equals 4 centimeters. There's another way you can do this as well. I know that this side is 2. This entire thing is 4 over here. So I know from this point down to this point, you would need an additional 2 to make those sides equivalent. So how do we solve this one? 2 is over here as well. So this would be 2 times 3 centimeters equals 6 square centimeters. And then you'd add those two numbers together, 10 square centimeters plus 6 square meters to give you 16 square centimeters. Because now I've taken the area of this one and I'm gluing it back to the area of B. So there's one way of doing it. Let's go ahead and take a look another way. Because there's usually one way that is typically more favored because it's arguably easier, or more so you're less likely to make a mistake in it. But there are other methods as well, and I want to go ahead and kind of experiment with those to kind of give an idea. Before, we cut left to right. Now we're going to cut from here up. Now, scholars, also keep in mind, can I cut like that? Technically, I can. Is that really going to help you with this, though? No. The entire idea is that we're trying to cut this in a way to get rectangular or squares from it so that we can, find the area. That would make your problem a lot harder. What if you cut right there? Well, you got this one, but now you still have this weird oblong shape right there. So typically, you want to cut this in a way that is making two rectangular or two square shapes. So I'm going to go ahead and cut right there. And we'll do the same thing we did before. This shape over here will be A. This shape over here will be, B. I'm already holding the green one, so let's just do B. So solving B here. Finding the vertical side length multiplied by the horizontal side length. Well, I am very tempted to say, well, actually, it's already done pretty well for us. We're not doing 5 centimeters because 5 centimeters is from this corner all the way to there. But I know from this point here to there is 3 by 4. So we're good on that one. Completely ignoring this, we know that this is a 3 by 4 or a 4 by 3, which will give you 12 square centimeters. And by the way, if we've done this right, it should give us the same answer as the other one. Should. 12 square centimeters. Now this other one though, this one is the one that's might come across a little tricky. Because once again, we only have one side length. We only know here to here, which is 2. So how do we find this point to that point where we've made our cut? Well, big thing here is you look at the full thing. It's this to this is 5 centimeters. So from here to here plus here to here equals 5. Once then it makes you go, okay, but I don't know what here to here is, which means I can't compare it. Remember the rule about rectangles and squares. Opposite sides are equal. If I know here to here is 3 centimeters, what's that? This up here is also 3 centimeters. So what plus 3 equals 5? 2 centimeters. So I know this is, if I had drawn this perfectly, this should be showing itself as a perfect square, but sometimes your drawings aren't going to be perfect, so run off those numbers. So this would be 2 times 2, which we go 4 square centimeters. 12 plus 4 equals 16 square centimeters. So it still gives you the exact same answer. Now, we've solved this in 2 ways. We have decomposed it into smaller rectangles. Now, next question is, what is this completing composite figures? So a composite figure is basically creating something that isn't quite there yet. It's kind of pretend things are there. And what I mean by this is we're going to pretend that this piece right here exists. It's still there. Because if you remember, we talked about in the last lesson that if I were to do 5 times 4, it would solve for this entire thing, including this area right there, which we don't want. We do not want that area right there. But we can actually use this as a strategy to help solve this problem. Let me show you what I mean. Let's solve for the entirety of this. 5 times 4. We get 20 square centimeters. Once again, we've done this problem twice already in 2 different ways, so we know the answer is 16 square centimeters. So you might be like, okay, so that's not 16 square centimeters. You're right, it's too big because we're doing too much. We're giving it too much area, which means now we need to take this and cut it out, which means we need to find the area of just this area and then subtract it from the entire thing. So how do you do that? Same thing you've done before. You need to find these side lengths. If I know the entire thing is 4, if I know I have 2 here, how much more do I need to get to 2? Well, 2. If I know this entire thing is 5, and here to here is 3, 3 plus 1 equals 5. 2. So 2 times 2 equals 4 square centimeters. And now do I add or subtract this from 20? Since I'm getting rid of it, I'm subtracting. So I do 20 minus 4, and that'll get us, well, you look at that, 16 square centimeters. So you run into many problems like this, but the biggest thing to remember, cut it into a location that will give you 2 rectangles or 2 squares, or a rectangle and a square, something that you can use to find that area, or solve for the whole thing, including a little extra, and then get rid of the extra. There's 2 methods that can do that. Both are very, very good. Both are very useful. You may be running into a problem that tells you to use a specific format. If it does, make sure you do the one that it tells you to do. Anyways, hopefully this was helpful. Hope it wasn't too confusing, and I hope you guys all have a good rest of your day.